This is about as real as it gets, because here we have a area of the world that many of you are familiar with. Good old Dauphin to Brandon. You've never seen that before? No? Okay. Well, many of you maybe you don't look at maps. I don't know. A small plane wishes to fly from Dauphin to Brandon. There's the city of Sunshine right there, right? And we're flying down there to Brandon, right there. Pretty much straight south. This is a distance of 166 kilometers, and that is true. I looked it up.
Is it?
Yeah. Brandon, you should listen here because this is yesterday's stuff review. So, the pilot has 45 minutes to make the trip. The direction to Brandon is south to east. I took a protractor and I measured it.
Like you're going south to east?
No, you're going south.
South and 2 degrees.
You look south,
Say
and you look 2 degrees to the east, right?
oh, there's no
Okay. Calculate the resultant velocity in kilometers per hour. So job number 1 is to calculate the resultant velocity. What has to be the overall resultant velocity in kilometers per hour? Go.
Do we need the time?
You do. Step 1 is just find the resultant velocity. How do you find velocity?
Add them. Subtraction and the magnitude.
I'm looking for the resultant velocity. Okay, I'm going to read body language, and I'm going to give a hint. You know the distance. It's 166 kilometers.
You know the time.
You know the time. Velocity is?
Oh, gotta find the kilometers per hour.
Yeah, that's. Calculate the resultant velocity in kilometers per hour.
You threw me for a loop there. Oh.
Me and my silly words. Yeah? Okay, so have you got that figured out? Hey, Cole, pay extra attention today.
But it's, no, I don't.
Have you got that resultant velocity figured out? Because it's just a few keystrokes, just doesn't take you long, right? So first of all, you got to convert that 45 minutes to hours. How many people put 0.45 minutes?
0.75.
0.75 minutes, right? 3/4. 45 divided by 60, 0.475 minutes. 0.75 hours, sorry. So you're going to take 166 and divide by 0.75, and what are you going to get?
221.333.
Okay. 221 point what? 333 kilometers per hour. And because it's a velocity, you're going to need to know that it's
Solid.
south to east.
Solid.
Okay, now,
Oh,
in many years past, as I've done this question, I've found that the math actually confuses people.
Why?
Because the map does not show velocities, the map shows distances, really, right?
Yeah.
Okay, so it's just there as a bit of a visual aid, but I found over the years that it actually, it hurts people because they want to try and do it, they want to try and do the question right on here, and it doesn't work very well. But I want you to stop and think. If this is the wind right there, the wind is blowing west 35 north.
Yeah.
West 35 north, right?
Yeah.
So if I want to go from, this is my resultant, if I want to go from good old Dauphin to stinky old Brandon, it's the opposite way? Okay. If I want to go there, but the wind is blowing me this, whoa, is that what I wanted? If the wind is blowing me that way, which way do I have to aim the plane?
this way.
To the right.
So like
And
hard.
down.
Or a
So
little bit
kind of like,
a little bit further.
kind of like that?
Like it's gonna have to be
It
along
needs
the
to
line.
pass.
You're right, it is, right? Okay, now, again, I'm going to point out, you don't actually get in your plane, fly right at Carberry, go past it, and then go, make it hard right and go to Brandon. It doesn't work that way, right?
Why?
Because you're going to actually end up flying this way, right? Well, I mean, you're going to fly, you're going to aim that way, but the wind is going to continue to push you. So you're actually going to go along that dotted line, right? Okay. Is this vector subtraction? It says determine the plane velocity required to make this trip. So you'll remember from yesterday, I showed you resultant is plane plus wind. What are we trying to find here? We're trying to find the plane vector. So that's going to be equal to, when you isolate that,
R minus W.
R minus W,
Or R plus W.
which is, thank you, Brett, R plus minus W. Because you said it yesterday.
Want to quit?
R, right? Remember I showed you this yesterday? How do you subtract vectors? You flip it and add. You flip it and add, exactly, right? Which one are we going to flip?
The wind.
The wind. So in this case here, right? In this case here, I'm going to get rid of this one here. Here's my R. Here's my W. So what am I going to do with my W? I'm going to
Arrowhead on the other side.
flip it. And how do you add? Tip to tail, and look where it ends up. South of Carberry, like we predicted. Right?
A little faster.
A little bit past Carberry. Okay, so now your job is, you can either do it on the bottom of that page or on the back side where there's more room, it's up to you. I would suggest don't do it on the map. The map causes you confusion. Because the vectors are actually velocity vectors, not distance vectors, and the map shows distance, right? So the map tends to cause some confusion. Okay, so go ahead. You're going to show me how that works now. You're going to draw this vector here, which is 221.3 kilometers per hour long. And then you're going to add the wind, which the wind is 25 long, and it should look like that. And then you're going to draw that, and it's going to be the plane. Okay. Clearly, I have not done a very good job here of explaining. So, what you guys need to understand is, and I had this little conversation with Jeff a few minutes ago, is a lot of you don't realize that what you really are looking for is the teacher to show you individually how to do things. And we can't do that. If we did do that, that's called a tutor. Right? There's a reason why there's 25 of you in the room. It's just more cost effective that way. We can't have one person per teacher. It doesn't work that way. Okay? So you gotta be engaged. When I'm standing up here talking, you have to realize, oh, he's teaching. I should listen. I should pay attention. Students that do that are generally successful.
Yeah, but there's some people that are dumb like me that actually need individual help.
I understand that, Cody, but you still have to try, right? Because you're going to get better at it. You can't wait for me to come to every person individually. It's not going to work. It's not going to be successful. You're not. It's not going to work. You also got to be here every day, whether you get your driver's license or not. I'm sorry, Cole. If that was a job and you just didn't show up, what would have happened? You know the answer.
I would have got a frowny face. I would have got a frowny face.
More than a frowny
A
face.
double frowny face.
Right? Like, I'm sorry not, but that's the way it is. All right, so let's go back to the question. Pencils down, eyes and ears open. Okay, I need you listening. Everyone, I'm explaining now. If I see you not listening, don't expect any help later. You're not doing your part, your share. Your share is listening right now. If I see a phone, it's gone. Like, seriously, gone. You got to pay attention. We got to figure out how to do this. A small plane wishes to fly from Dauphin to Brandon. This is a distance of 166. The pilot has 45 minutes to make the trip. The direction of Brandon is south to east. Calculate the resultant velocity in kilometers per hour. So what is that? That is our vector R. That is resultant velocity. And we worked it out to be 221.3 kilometers per hour. And I told you it's at south to east, right? That's the resultant velocity. That's what has to be the result of this interaction. Okay? The wind speed is this. So what vector is that? That's the W, wind. Right? You are to determine the plane velocity required to make the strip. So we're solving for the P. I got R, I got W, and I got P. Right? Those are the three vectors. I've told you already that the resultant is the plane plus the wind. And I showed you this yesterday. How do we find the plane? We're going to isolate for P. We're going to get rid of everything else. The P goes to the other side and it becomes negative P or negative W, right? The W goes to the other side, it becomes negative. And so I get P equals R minus W. I showed you yesterday that subtracting vectors, you can add the opposite. So we're going plus minus W. How do you add the opposite? You got to take that wind and you got to flip it and then add. That's what we went through yesterday. Flip it and add. So I took the wind and I'm gonna flip it. There it is right there. Minus wind. This vector here is going to be your P. Your plane vector. That's going to be your P value. Yeah. Okay, so now what I'm going to do is I'm going to flip the page over because the map's confusing. As I said. Okay, and I rewrote down R equals, you should do the same. Here's where I should hear 25 pages flipping over. Thank you. And then I should see people writing R equals 221.3 and W equals 25 at west 35 north. And I guess we should also have this resultant was at south to east, I think, right? Am I right about that? South to east? Okay. Do you need a scale diagram? You do, because it's not Pythagoras, it's not a right triangle. So now I need a scale. 1 centimeter equals. Now what are the numbers I'm dealing with? One of them is 221. The other one is 25. Well, 221.3 is not going to divide nicely into something, is it? We're just going to have to deal with that. 25 is nice. That means 4 centimeters would be 100. 8 centimeters would be 200. 9 would be 225. I think that's going to work. Right? So I'm going to say 1 centimeter equals 25 kilometers per hour. That's my scale. 1 mark for that, Cody. Did you understand how I got the scale? Why not? So you've given up already? No, Cody. Did I not just explain that? Which part did you not get? Let's go back and do it right now. No, Cody, you can't. You have to get up to here. It's not hard. How did I get that scale? I've got 221.3 and I've got a 25 that I have to work out. And I said to myself, well, if it's 1 centimeter equals 25, then 100 gives me 4 centimeters, 200 gives me 8, 225 would give me 9. That's going to work. That's all I did. 1 centimeter equals 25. Zane, you know where the 25 comes from?
Yes.
Excellent. You're just saying that so I won't pester you, though. I can tell. Okay, so now I need what am I going to do? Remember, I'm going P is equal to R minus W. So I got to draw my resultant vector. Okay, now, how do I know how long to draw it? Now, most of the time you can do this in your head, but in this case, it's not going to work, is it? You're going to have to actually go 221.3 divide by 25 to figure out just how long this vector is going to be. 221.3 divided by 25. 8.852. Should we say, let's make that 8.9 centimeters. Okay? Round it up, actually. 8.9 centimeters. Okay. South to east, so I got to draw my reference line. There's south. And I need a protractor. And said protractor has to give me south to east. So I'm going to my protractor like that. I'm going to put it at the north end because I'm looking south. right? I'm looking at the north end of the line, I'm going south, and 2 degrees is like right there. Right? 2 degrees. South to east. South, 2 degrees east. Okay, and I got to go 8.9 centimeters. So now I need a ruler. Say that again, Jeff? All I'm doing there is finding out how long the vector is. Man, that's all I'm doing. How far to draw it. That's all I'm doing.
Because we're doing 1 centimeter.
1 centimeter is equal to 25 kilometers per hour. It's 221.3. So how far do I draw? Remember we did scale drawings a while back, right? You guys also got to realize that every day I keep adding a little bit more knowledge to you, and if you don't get it, the next day is going to be harder and harder and harder, right? Yeah, you got to be with me every day, and you got to get it. You cannot just leave it to the end. It's not going to work. You got to stay with me. Okay, 8.9 centimeters.
Isn't that going south though?
Yeah.
Okay, so east.
South to east, Zane. Look at the question. South to east, right?
South 2 degrees east.
South 2 degrees east.
So wouldn't it be over?
South, east. East is to the right. Remember like a week ago?
Like a week ago. Wouldn't it be? Only 2 degrees.
I know. That's a week ago, man. Okay, 8.9 centimeters. 8.9 is right there. Stay with me, you guys. Okay, so there's the resultant in red. We're doing vector subtraction, so we flip it and add. So my vector, my wind vector is not west 35 north. Minus wind is going to be 25 at, not west. East 35 south. East 35 south. And I'm going to add that to this one right here. I'm going to add it, which means tip to tail. So east 35 south. East from here, east 35 to the south. 35, right there, right? 10, 20, 35. Get rid of the protractor. Now, how long is that? It's 25 kilometers an hour. My scale is 1 centimeter equals 25 kilometers an hour. So, 25 divided by 25, it's only 1 centimeter long, right?
Yeah.
1 centimeter long.
Yeah, the map was screwing me up.
Did I not say that?
You did. You got your time.
If nothing else, you guys, you might learn that I know what I'm doing. And you should listen. I know, Cody, yeah. So what is it? 35? No. East 35 south. This is year 26.
Year 26.
Yeah.
Yeah, listen.
Thanks, Cole. East 35 and only 1 centimeter long. So I'm going to do it in a different color. Right there. And that one is, I should label that minus W, because that's the negative wind. Cody, you got to stay with me. You're not going to get it if you're having a conversation. There's no way around it. You have to listen to me. There's minus W. So now I'm solving for the plane. And I go from where I started. I should really put arrowheads on these. Go start where you started. And you're going to go to where you finished. So we're going to draw, and I'm going to put it in a dashed line just because. So we're going to go from there to there. And that's going to be labeled our plane, our P. Okay? How do I know what the plane vector is? Do I use Pythagoras? No. How come? Not a right triangle. What happens if you do a right triangle? Frowny face. Don't do it. You're going to have done a lot of work and get nothing out of it. Exactly. So we're going to take our protractor and we're going to actually measure. Ruler, thank you. And we're going to measure. So it looks to me to be about 9.7. We'll say 9.7 centimeters. Now, how do I convert that to kilometers per hour? Multiply by 25. Exactly. You guys are getting this. The ones that are paying attention.
25.
So 9.7 times 25, 242.5. That's going to be kilometers per hour. Yeah? Oh, yeah, that's fine. It's plus or minus 3 millimeters. Yeah. Okay, now I got to measure with the protractor. I'm almost done. And I realize that this has been a long little deal here. So, now remember at the start that I told you you must measure from one of the reference lines, right? I already have a reference line that, well, I don't really have one either anywhere to do it. I just put my protractor on. So you might have one. My protractor's like that. I'm going to measure from east because my protractor will do that nice for me. It'll sort of flatten right off. So I'm going to measure from east, so it's going to be east. How many degrees? 10, 20, 30, 40, 50, 60, 70, 80. Looks like 83. East, 83, south. It could be south, 7, east, right, Brett? Yep, absolutely. So what that means, Jonathan, is the plane has to head out in a direction of east 83 south, and with a speed of 242 kilometers per hour relative to the wind, and the wind will push him back towards Brandon.
This is all something that, like, it's the same time on the trip, right?
Exactly. The wind remains the same the whole time. You're right.
But, like, they get to the place at the same time, right?
You gotta make sure they have enough fuel to make it happen.
That's correct.
Like, would they increase their speed, or would they just take longer to get where they're going?
They might just take long. I mean, they recalculate every sort of, I mean, flying to Brandon, someone knows they're going to, you don't do this when you're flying to Brandon, right? But if you're flying from Toronto to London, England, right? Yeah. And in fact, I read a book not long ago about one of the big planes, and as it was flying across the ocean, they would actually have to calculate the wind speed. Think about, I'll get to this, sir. Then they'd have to know how much fuel they had and whether or not they had enough fuel to get to the other side, Newfoundland. And if they did, they'd have to turn the plane around and go back. Like if the wind was too high, or if there was a storm that they had to go around, then if they had to figure out how much fuel they had, and if they didn't have enough, they have to go back. Because if you don't have enough fuel,
Well, you might as well just cross that engine.
okay. Enough of me talking. Time for you guys to practice on your own.